All right, let's do some homework problems. Let's start with number 32 from the textbook. Number 32 says something. Use the vertex and a point to find the general form. Okay, just like the ones that we did in the earlier video. So the vertex, HK, is going to be 0, 1. And the random point it gives us is 1, 0. So the whole idea for that is that vertex form is a times x minus h squared plus k. So we use this h and this k, and that gives a is equal to x minus h. H is 0, so we're just going to have x squared plus k, which is 1. And we still don't know our a, but we're close here. So now we use this x and this y to find a. Y is 0, x is 1. Solve for a, should get a equals negative 1. So y is equal to negative 1, or you can just leave out the 1, times x squared. We don't need the parentheses either, plus 1 like so. This should have the right vertex. This should have the right point. You can check by graphing it. That would be a good thing to do. Or we can move on to the next one. For problem number 40, write an equation for this graphed function. There are two methods. I'm going to use the method that we just used, okay? Because it's a little easier. It's longer, but it's usually easier. The other one is quicker, especially if you don't have fractional values. And here we don't have fractional values, so the other method's actually really good here, but let's show it off. So we're going to say this is y equals a times x minus h squared plus k. And our vertex is 2, negative 3. We're going to get y as a times x minus 2 squared plus a negative 3. Now we pick any point we want. Any point on this graph other than the vertex, which we've already used. We can use the y-intercept. We could use anything else. This is the point 0, 1. Plug that in. Y is equal to 1. X is equal to 0. Add 3 to both sides. You should get that a equals 1. So our answer for number 40 is just x minus 2 squared with a 1 in front of it, minus 3. Or you could use function transformations. This is the standard parabola. Move to right 2 and down 3. Right 2, down 3. Is there vertical stretching? Is there a negative? It's opening up, so there's no negative. And normally parabolas go up, right 1 and up 1. Oh, ours did. They normally go right 2 and up 4. Oh, ours did. And so on. So a value has to be 1. Let's do another problem. 48. Okay, very similar. Use this table. And again, you can either graph it or not graph it. It's up to you. I think it's a little easier if you graph. Obviously, it takes a little longer, but if it makes things easier and you get the right answer, why not, right? If we graph this, graph these points, on number 48, that's negative 2, negative 2, negative 1, positive 1. What problem are we even doing? 48? 0, 2. Positive 1, and positive 2, positive 2. So we could plot those points. And we do that we get this parabola. When we look at this parabola, we can answer the questions that it wants. It wants us to find the vertex, axis of symmetry, and general form. Let's find the vertex, let's find the axis of symmetry, and then general form. We'll put all of our answers up here. Axis of symmetry is going to be the line x equals 0. Always a vertical line. The vertex is the point 0, 2. Let me make sure there's nothing else. Yep. So just need general form. So y is equal to a. We don't know a, but we can find it out, right? Normally parabolas go right one, up one. Our parabola goes right one, down one. So a is just -1 times y whoa, where did that y come from? Times x minus h plus k. Expand that out. It's going to become -x squared plus 2, and that's general form. There we go. Do one more problem. Let's do problem number 71. Suppose that the price per unit in dollars of a cell phone production is modeled by P equals $45 minus 0.0125x. I'm already going to tell you, we're going to need to write that down. All right, 71. We don't need graphs here. P equals $45 minus 0.0125 x in dollars, or x is in thousands of phones produced, and revenue is thousands of dollars. Wait, hold on. The price per unit in dollars, P is price per unit. X is thousands of phones. What else do we have? The revenue in thousands of dollars is R equals X times P. I guess, right, is price per unit just in regular dollars to produce one. So this means that if we're not producing a lot of phones, then the price is $45 to produce one. But like with production, with mass production, it costs less to produce more phones per phone. You're still paying more, right? But you're making a lot more phones. And that also has something to do with like marginal cost. Here, the marginal cost here is actually going to be like 1 cent. Interestingly enough, 1.25 cents for all of the phones. I believe. Anyway, so find the production level that will maximize revenue. This is what we want to maximize. And so this time we actually can skip a couple steps in the application section, step-by-step process, because we're already given our constraint. Not only are we already given our constraint, but it's actually already solved for P anyway. So all that's left is plug this in for P so we get our quadratic function. So R is equal to X times P, and P is 45 minus 0.0125X. Distribute that X and move things around to get it in general form. We're going to get R is negative 0.0125X squared plus 45X. That's our revenue function. We want to find the value of X that maximizes its revenue. This is A. This is B. The maximum or minimum, because again, A is negative, so there's a maximum here. The max occurs at the axis of symmetry. When X is negative B over 2A, or negative 45 over 2 times negative 125. We'll use a calculator for that one. Negative 45 divided by 2 times negative 0.0125. That's 1800. So the maximum is when X is 1800. That's 1.8 million phones. Right? X is in thousands of phones. What else are we asked to do? Find the production level that will maximize the revenue. Yeah. 1.8 million phones. To find the maximum revenue, which we were not asked, we could just plug it into this formula. And that would tell us how much this company is making when they're producing 1.8 million phones. That seems like a lot. Remember, you can check your answers to all the odd questions in the book. So just click on that 71, and then it should link you to the answers. I don't know. I wonder if it's Firefox or something, but some weird things are happening with this web page. So depending on your browser, it may scroll all the way down. 5.1, number 71, the revenue reaches the maximum value when 1,800,000 phones are produced. So 1.8 million phones. That's our answer. Great. Let me know if you have any questions and good luck.